So what is an absolute value function? Let's just do a quick review. In simplest terms, an absolute value function is a specific piecewise function. It is that classic V-shaped function. And our absolute value function can be written as the f of x is equal to the absolute value of x minus a. Now, if we remember back from pre-calculus, the absolute value of x minus a can be broken up into the positive piece and the negative piece. So we'll go ahead and we'll break this up. We can see that our absolute value is equal to the negative piece, negative the quantity of the inside, when x is less than a. And then when x is greater than or equal to a, we would use the positive piece x minus a. So if we were to look at this on a number line, we can see that this is all centered around x equals a. And when we look at all the x values that are less than a, meaning all the ones that are on this side of a, we would want to use the expression negative parentheses x minus a. So in this case, this would be for all the values to the left of a, we would use negative the quantity x minus a. Well, for all the x values that are greater than or equal to a, so including a or greater than or equal to, we would want to use the expression x minus a, or for all of our values to the right of a, we would want to use x minus a. And the thing to mention here is notice that everything is centered around our a value. All right, so let's take a look at our first limit of an absolute value function. So here we want to evaluate the limit as x approaches negative 2 of 5 times the quantity x plus 2 over x plus 2. All right, so before we do that, let's take a look at how our absolute value function compares to the general absolute value function. And what do I mean by that? Well, our general absolute value function is f of x is equal to the absolute value of x minus a. Well, in this particular case, we don't have a minus, we have a plus. But we know that we can rewrite a plus as minus a negative, and that'll allow us to identify what our a value is. So we can go ahead and we can write that. So we can rewrite this limit as x approaches negative 2 of 5 times the absolute value of x minus negative 2 all over x plus 2. Now, if we notice, our a value for the absolute value, which we can now see is negative 2, matches the a value that the limit is approaching. And that is key here, because this means that the absolute value also revolves around the number we're approaching. So, if we were to draw a number line to kind of set this up, we know that we are approaching x equals negative 2. For all the values less than negative 2, we're going to use the negative piece of the absolute value function. So negative the absolute value of x minus negative 2. And for all the numbers greater than negative 2, we're going to use the positive aspect, x minus negative 2. So that means when we're looking at the limit coming from the left-hand side, we would use the negative piece. And when we're looking at the limit coming from the right-hand side, we would use the positive piece. Now, let me just move this guy down a little bit to give me a little bit more room. All right, so this means since we're looking at a two-sided limit, that means that we have to take a look at each of the one-sided limits. So I can break this absolute value limit apart. So I'm first going to have the limit as x approaches negative 2 from the left. And this is going to be 5 times the quantity. Now, since we're approaching from the left, we're going to use the expression negative x minus a negative 2. And that's all divided by x plus 2. And then we're going to take a look at the limit as x approaches negative 2 from the right. And it's going to be 5 times the positive value, so x minus a negative 2 all over x plus 2. All right, so then from here we can just evaluate these two limits, and I'm going to go ahead and simplify some things. In the top limit, I'm going to say that the minus and negative, that's going to turn back into pluses. And then when I multiply 5 times a negative value, that's going to become negative 5. So I'm going to be left with x approaches negative 2 from the left of negative 5 times x plus 2 all over x plus 2. And for the right-sided limit, this is just going to be the limit as x approaches negative 2 from the right. I'm going to change the minus negative back into pluses again to give us 5 times x plus 2 over x plus 2. Well, then if we look at these limits, the left-sided limit, that expression has an x plus 2 in the top and an x plus 2 in the bottom, so that'll cancel out. Same thing with our right-handed limit, x plus 2, x plus 2. So that means for our left-handed limit, we're just left with a limit of negative 5. And we know the limit of a constant is just a constant, so that'll be negative 5. And then for our right-sided limit, we're left with positive 5, and the limit of positive 5 is going to be positive 5. So now when we compare each of the one-sided limits, we can see that the left-hand side does not equal the right-hand side. So therefore, the limit as x approaches negative 2 of 5 times the absolute value of x plus 2 over x plus 2 does not exist. So, solving limits of absolute value functions in a way is similar to solving absolute value equations, where we do need to break it apart into its two separate functions. All right, so next up we're going to take a look at a similar example. Here we have the limit as x approaches negative 7 of 5 times the quantity x plus 7 over negative 2 times the quantity of x plus 7. Again, here we have an x plus a number. So I'm just going to come over here and I'm going to rewrite this to be x minus a negative 7 is inside the absolute value. And when I do that, I can see that the a value in our absolute value matches the a value in our limit, which tells me that we need to split this two-sided limit up into its two individual one-sided limits. So we're going to do this again. So we're going to have the limit as x approaches negative 7 of 5 times x plus 7 over negative 2 times the absolute value of x plus 7. And I can break this apart into its two one-sided limits, the limit as x approaches negative 7 from the left, and the limit as x approaches negative 7 from the right. Now remember, when we're approaching from the left-hand side, we want the negative piece of the absolute value. So our expression is going to be 5 times x plus 7 all over negative 2 times negative the quantity x plus 7. And then for the limit as x approaches negative 7 from the right, we're going to choose the positive piece of our absolute value function. So we'll have 5 times x plus 7 all over negative 2 times x plus 7. And then we can simplify and evaluate these limits. Let's see, this is going to be the limit as x approaches negative 7 from the left of 5 times x plus 7. For the denominator, we're going to end up with a negative times a negative, which means this is going to give us a positive 2 times x plus 7. And for our limit from the right, we're going to get the limit as x approaches 7 from the right of 5 times x plus 7 all over negative 2 times x plus 7. And then from here, for both of our one-sided limits, we can see the numerator and denominator both share a factor of x plus 7, so that would cancel out. So then in the upper limit, we're just left with a constant of 5/2. So therefore, this left-handed limit is going to equal positive 5/2. For the right-sided limit, we're left with a constant of 5 over negative 2, so that means this limit is going to be negative 5/2. Now, as we see, our one-sided limits do not meet at the same spot, so therefore they are not equal, and therefore our two-sided limit, the limit as x approaches negative 7 of 5 over x plus 7 over negative 2 times the absolute value of x plus 7 does not exist. All right, so let's take a look at another one. Here, we want to evaluate the limit as x approaches 3 of negative 2 times the absolute value of x minus 3 all over 3 times x minus 1. Now here our absolute value is x minus a number, so we can see that our a value is 3, and our a value in our absolute value function matches the a value of the limit, which means we can break it apart into its two one-sided limits and its negative and positive piece. So we're going to take the limit as x approaches 3 of negative 2 times the absolute value of x minus 3 all over 3 times x minus 1. And we're going to get the limit as x approaches 3 from the left, and we're going to look at the limit as x approaches 3 from the right. Now remember, from the left we want to look at the negative inside. So that means our inside is going to be negative times the quantity x minus 3. And from the right we're going to be looking at the positive aspect. So we're just going to have the regular x minus 3. All right, then for the left-sided limit, we can see the negative and the negative are going to cancel out. So we're going to be left with the limit as x approaches 3 from the right of 2 times x minus 3 all over 3 times x minus 1. And for the limit from the right-hand side, we're going to get the limit as x approaches 3 of negative 2 times x minus 3 all over 3 times x minus 1. Now, this one's a little bit different because we don't have a factor in the numerator and a factor in the denominator, so there's nothing we can cancel out. So all we're left with here is direct substitution. So we can substitute these values in, which means we're now going to drop the limit notation to get 2 times 3 minus 3 all over 3 times 3 minus 1. Let's see, 3 minus 3 is 0. 0 times 2 is 0. Over 3 minus 1 is 2. 2 times 3 is 6. But that really doesn't matter because 0 over any number is just going to be 0. All right, looking at the right side limit, we're going to get negative 2 times 3 minus 3 all over 3 times 3 minus 1. And we're going to end up with 0 over 6 again, or 0. So in this particular case, the limit from the right does equal the limit from the left, and they both meet at 0. So therefore, the limit as x approaches 3 of negative 2 times the absolute value of x minus 3 all over 3 times the quantity x minus 1 is going to equal 0, because in this case, the two-sided limit does exist, and it exists where the one-sided limits meet at 0. All right, so our next example asks us to evaluate the limit as x approaches negative 4 from the right of 5x plus 20 over the absolute value of x plus 4. So even though we're looking at a one-sided limit, in this case limit from the right, we still need to find our a value for our absolute value function. And here we have x plus 4, which we're going to be able to rewrite as x minus a negative 4. And just like in the other examples, we can see that the a in the absolute value matches the a that our limit is approaching. So therefore, we can pull apart this function. But remember, we're only looking for the limit as x approaches negative 4 from the right, which means from the right, we're looking for the positive inside. So I can rewrite this limit to be the limit as x approaches negative 4 from the right of 5x plus 20 over the positive piece, which is just x plus 4. Now, if I would plug in negative 4 here and do direct substitution, we would end up with 0 over 0, which means we would have to factor and cancel. So let's go ahead and let's factor this. We're going to have the limit as x approaches negative 4 from the right. In the numerator, 5x and 20 both have a factor of 5, so I can factor out a 5 to get x plus 4. And that's going to be over x plus 4. And here we can see we have a common factor in the numerator and the denominator, so those will go away, cancel out, leaving us with the limit as x approaches -4 from the right of 5. And the limit of a constant is just that constant, meaning that this limit is going to equal 5. And our final example, we're going to evaluate the limit as x approaches 7 from the left of 5 times the absolute value of x minus 7 over x minus 7. So let's first identify our a value of the absolute value function. That's going to be 7. And as we can see, that matches our a value for our limit. So that means we can split this apart. But we are taking a look at the limit as x approaches 7 from the left, which means we want the negative piece of the absolute value function. So I can rewrite this limit as being the limit as x approaches 7 from the left of 5 times the negative piece, so negative quantity x minus 7. And then that's all over x minus 7. And then we can continue simplifying. This is going to be the limit as x approaches 7 from the left. 5 times the negative will be -5 times x minus 7 all over x minus 7. And for this particular limit, we see we have a factor of x minus 7 in the top, a factor of x minus 7 in the bottom, so they cancel out, leaving us with the limit as x approaches 7 from the left of -5. And since that's a constant, our answer is going to be -5.